Some people say mathematics is all about finding patterns. If I start with the number 1 and then the number 4, followed by the number 9, you might believe a pattern is emerging. What number would come next in the sequence? Many people would say 16. But those people would be wrong, because the next number is actually 15. Yep, 15, not 16. Don't believe me? 1, 4, 9, 15. Yep, 15 is definitely the number we're looking for. And I can prove it. At your tables, calculate what happens when you substitute 1 in for n, and then 2 in for the variable n, substitute 3 into n, and finally put the number 4 into the formula. Whoa! How could that be? How did he come up with that formula? It's a special process called the method of finite differences. So, let's start by examining our original sequence, and we'll use it to help us determine the degree for our formula, the one that generates 1, 3, 9, and 15. We find the differences between the original numbers, increasing by 3, then by 5, and then by 6. Next, we process another round of differences, this time finding a difference of 2, and then a difference of 3. And you've probably guessed it, we'll do one more round of finding differences, ending with a difference of 1. And now, because we've run out of being able to find differences, we can count the number of, quote, difference rows to determine that the degree of our closed formula should be a third-degree polynomial. This allows us to write what is called a dummy formula. So, we start with some number, we'll call it a, times n, raised to the third power. That's where that third degree comes in. And continue writing the dummy formula, plus some number times n squared, plus some number times n, plus some number. Now, the reason this is called a dummy formula is because a, b, c, and d are only dummy placeholders. We need to find what specific values should go in for a, b, c, and d. Values that will help us to generate the sequence 1, 4, 9, and 15. To find those specific values for a, b, c, and d, we break step 3 into a series of smaller steps, starting with writing a system of equations. Now, we know we want an input of 1 to give us an output of 1. So that means a times 1 cubed plus b times 1 squared plus c times 1 plus d will need to equal 1. Likewise, an input of 2, in other words, the second term of the sequence, should result in an output of 4, meaning a times 2 cubed plus b times 2 squared plus c times 2 plus d will need to equal 4. Continuing on, we see that a times 3 cubed plus b times 3 squared plus 2 times 3 plus d must equal 9. And finally, a times 4 cubed plus b times 4 squared plus c times 4 plus d will need to equal 15. And now we have 4 equations. And let's simplify the exponents a little bit, giving us these 4 equations and 4 unknowns. And now we're going to work on solving for a, b, c, and d. To do that, we'll write a matrix. In other words, a shorthand for the equations. A shorthand that strips away all of the variables, leaving only the coefficients of the 4 equations. So rather than solving by hand, we can enter this matrix into a website and have it solve the problem and determine the values of A, B, C, and D for us. Let the matrix do all of the numerical manipulation. And all we need to do then is to interpret the result. This result matrix has solved our problem for A, B, C, and D. It tells us that A equals -1/6, and B is 2, with C being -11/6, and finally D equals 1. Thus, we can rewrite the dummy formula, replacing the values that we found for the letters A, B, C, and D. And you'll notice that's that formula that gave us 1, 4, 9, 15. Voila!